Hello everyone, I'm Chandrasekhar. I'm with the engineering team at Sedai. I have here with me Nate Singletary. He's a senior SRE with the platforms team at KnowBefore. Today we'll be covering some of the aspects of using an autonomous system like Sedai with a CICD workflow or pipeline. We'll also be looking at some of the strategies how Sedai can be integrated or any autonomous system can be integrated with the CD systems. Nate will also be sharing some of his experience in using Sedai in KnowBefore, especially integrating with the CD section. Continuous integration and continuous deployment systems has been in the industry for several years now. We've got a lot of mature products. We've got a few listed on the slides: Jenkins, Argo CD, Circle CI, GitLab CD, just to name a few. Continuous integration systems have promoted detecting problems much early in the development life cycles. This is usually done by running automated builds, running unit test cases, integration test, vulnerability scans, and so on and so forth. Continuous delivery systems, while have streamlined the process of shipping the software into the target system in a very streamlined way and in a very repeatable fashion. Together, CI and CD has effectively increased the number of software release cycles in a much faster pace. So we have got very less lead time for any features to hit the target systems. One of the key aspects of the CD systems has been infrastructure as code. The core aspect here is infrastructure. The state of the required infrastructure is defined as code without really specifying or imperatively defining how the hardware is realized. So all the good things that I usually get from code repositories is now available to hardware systems. This include auditing, versioning, collaborating, and of course, it creates a repeatable form of generating hardware. And hardware is now reproducible if there is a scenario to do that. Now, the glue that brings together the infrastructure as a code and the realized hardware is usually called the GitOps. So it's all the bells and whistles that surround the GitOps, Git repositories. So here is an example workflow which uses CICD to ship a software into a containerized target system. The process starts with somebody pushing software code into the source code repository. Those changes are picked up by Jenkins, which is actually the CI systems in this case. It runs builds, it runs unit test cases, and if everything goes well, it creates a Docker image and pushes those changes into the Docker registry. So the next thing it does is it actually updates another source code repository, this time for infrastructure. It updates the new software release, which has been just created in the previous step. As soon as the source code repository for the infrastructure is changed, the change is picked up by the CD system, in this case Argo CD, and it pushes it out into the Kubernetes clusters. Kubernetes clusters picks up the updated Docker image from the Docker registry, which has been created in the previous step. Now, let's look at how an autonomous system fits into this whole cycle. The key factor or key advantage of an autonomous system over an automated system is that it can automatically detect topology. It can read metrics from the monitoring providers. It can correlate the metrics to the topology, build a model which takes into account seasonality, traffic, the resource usage, the outcome, the output of those applications, and then it understands what all opportunities are available. It can detect problem signals. It can generate solutions to those problems. It can figure out how to act on those opportunities. And being in an autonomous system, it is going to apply those changes in production. Look at the efficacy of the changes that has been made, learn from those changes, and not only by the changes that has been made by an autonomous system, even external system. And then it usually circles this whole process, doing a continuous optimization and availability fix 24/7. Now, as you can imagine, there are certain attributes which are being handled by an autonomous system, which needs to be handled by an autonomous system to be effective. And these are some of the things which are already defined in a CD system. We have already heard about this shift left, right strategy. Shift left, you want things to be solved earlier in the development cycle. So let's take an example of a web application and its runtime attributes. The amount of memory that is required, the CPU that is required, and the number of replicas that is required for that web application could come from the dev team. Fair enough, because they probably have the most insights into how that application works. But we all know that in production, things could be a lot different. A lot of companies try to establish some kind of a performance testing system to get as close to a production environment. But in reality, production systems are usually very different. There are so many things that attribute to that one. It could be the changing traffic, seasonality, it could be dependent applications, underlying infrastructure. And with the CICD system advancements that we have right now, we have a lot of changes happening to the software. New and new features are coming into the production very early, much faster. So that means the nature of the applications itself is changing. To really keep up to this one, you need like a system that is continuously optimizing things. We know that it is going to be super hard for any human or any automated system to handle. So what we suggest is that instead of shifting it to the left or to the right, let it be handled by an autonomous system, which we are calling shift up strategy. So effectively, what we are suggesting here is do not put any of those runtime attributes which are handled by an autonomous system. Instead, point that these things are being handled by an autonomous system. This approach is not too much different than, say, an application which does not have an autoscaler, a horizontal autoscaler defined, and the one which has an autoscaler. So if it doesn't have an autoscaler, that means the number of replicas which is required to handle probably the worst case scenario is defined in IaC. But we all know how efficient an autoscaler could be. With that, the number of replicas are really determined at the runtime, which means it is not defined in IaC. With autonomous systems, this is pretty much the case. Everything that can be handled efficiently in runtime should be just left to that autonomous system to handle, and there should only be hints to say that it is being handled by an autonomous system. Now, here we have come up with a few different strategies on how Sedai can be integrated with the CICD systems. There is no one size fit all we could figure out. We have worked with a lot of customers. Nate has especially helped us streamline some of these processes, and he'll be sharing his experiences next. But just to go through those strategies, the first one is very similar to what I just mentioned. Let an autonomous system manage everything during runtime. That means you only provide hints as to what an autonomous system should do, but not any specific runtime attributes at all. The second one is what we call as autonomous system sync. When we designed Sedai, we always had it in mind that this is probably not, Sedai is not the only system which will be managing a runtime configuration. There could be so many reasons that another system could be making changes. So if such a thing happens, Sedai already adapts to those kind of situation. It'll relearn from the changes that is happening, and it continuously does its thing in the normal way. With this extra setting, we are giving a hint to Sedai that there is really a CD system which is not getting inputs on what Sedai is doing, which means it could get overridden. In those cases, Sedai will actually try to reapply those configuration if it is safe to do so. If not, it'll just go with its regular learning process and continuous optimization. Now going to the third approach. This is where a customer has some leeway, some option to put some additional scripting in place to actually pull Sedai's recommendation into their CD system. So we have two options, either a pull or push based option, with which customer can programmatically request what the recommended configuration for any given resource is from Sedai at that given point of time. Using that one, they can pull the information, put it back to the CD system. And the fourth one is where Sedai can directly integrate with customers' IaC repository. So in this one, we need additional information about customers' Git repository. We support a lot of standard formats like Helm, JSON, YAML, Kubernetes deployment specs, Terraform templates. With all this additional information, every time Sedai makes a change directly into the cloud provider using the APIs, it'll also create a PR with exactly those changes, and which can be reviewed by the customer and merged back into the Git repository. So those are some of the options to integrate. Now I'll welcome Nate to share his experience about integrating with Sedai. Welcome, Nate.
I'm Nick Singletary. I'm one of the senior SREs at Noble4 in the platform engineering group. So a little bit about Noble4. We're the provider of the world's largest security awareness training and simulated phishing platform. We're used by more than 34,000 organizations globally. And we have the largest security awareness training content or largest security awareness training content library. Sorry about that. We have a diverse suite of products ranging from our security awareness tools to our human detection risk tools, from security orchestration tools that can identify malicious emails and rip them out of your inbox and turn those attacks into real world training opportunities for your users, spread across thousands of microservices and functions and data stores, and it's all deployed in AWS. So our platform architecture today looks like we deploy all of our code in GitLab, or we commit all our code in GitLab. All of our CICD runs in GitLab. All of our production workloads are deployed in AWS, and all of our monitoring happens in Datadog. But today we've also adopted an autonomous system, Sedai, to handle the autonomous right sizing of our workloads, of our ECS tasks, Lambda functions. But the next step in that process is completing that feedback loop. And when we started to do some work with that, with our integrating Sedai with our CICD workflow. So I kind of talked about this earlier today, but our current phase is the run phase where we're integrating Sedai into that CICD workflow. So today, taking the example of ECS, we commit code in GitLab. Our CICD workflow looks like the following. We commit code in GitLab that may trigger a build job in GitLab that deploys that ECS image into ECR. And then some infrastructure code gets deployed in AWS. Now, at the same time, while that's continuously happening, continuously releasing and deploying, we also have Sedai working and analyzing our workloads and optimizing them. So what we ran into, where there were some collisions of if Sedai is continuously optimizing our workloads and updating configs, and we're continuously pushing code, how do we not overwrite the configs that Sedai updates? So one way we did that was by pulling the current config after Sedai makes a change and using that at the time of the deployment. But then you don't have your IaC is no longer your source of truth for what your configs are. So what we did was, what we're in the process of doing is integrating Sedai into our GitLab. So we opened up our GitLab instance to Sedai, allowing them to come back, and once they make an optimization for a service, they can generate a merge request, and that config now goes back into IaC. We don't introduce that engineer back into the process to have to manually update these configs to ensure that we maintain the optimized configs. And now we have a full autonomous feedback loop. So just some of the highlights from our journey, we have, of the 9,500 services we have in Sedai, 98% are autonomized or set for autonomous optimizations. 1,100, we've had over 1,100 plus autonomous actions in 3 months. We're actually trending towards 27% cost reduction, and we've already achieved 10% savings. And as far as the CICD integration phase, we've been able to generate a successful MR request from Sedai after an autonomous action.